area of Nepal is situated in a region known as the Alpine Belt. This area stretches from Java to Sumatra, through the Himalayas, the Mediterranean, and out into the Atlantic. With 17% of the world's largest earthquakes occurring in this area, it is known as the second most seismically active region in the world after the Circum-Pacific Belt, also known as the Ring of Fire. On April 25, 2015, Nepal experienced a 7.8 magnitude earthquake, lasting approximately 50 seconds. The epicenter of the quake was situated 34 kilometers southeast of Lamjung, Nepal. The earthquake focus was around 15 to 20 kilometers deep, which is considered to be a shallow earthquake, therefore more damaging than quakes originating deeper in the earth. After the breakup of Pangaea, the Indian plate travelled around 6,000 kilometers, finally colliding with Asia around 40 million years ago. Because the Indian plate is more dense, it subducted under the Eurasian plate, resulting in deformation and uplift of the Eurasian landmass. The Indian plate is pushing its way north towards the Eurasian plate at a rate of around 5 centimeters per year. Geologically speaking, this is very fast. This movement is what created the Himalayan mountain ranges over 40 million years ago. The April 2015 quake has been the biggest, most devastating natural disaster to hit Nepal since 1934, when Nepal experienced an 8.0 magnitude earthquake which killed around 12,000 people. For up to 2.5 months after the initial quake, Nepal experienced aftershocks of 4.0 or higher. In the first 24 hours alone, 31 aftershocks were recorded. The May 12 aftershock quake in Dolakha was the most severe, measuring 7.3 on the Richter scale. This massive aftershock left another 218 people dead and a further 2,500 people injured. This quake is still considered shallow, as only measuring in at a depth of 18.5 kilometers deep. An avalanche on Pumori occurred the same afternoon as the initial quake. Shaking from the quake was said to have triggered the avalanche, which killed at least 22 people and left 61 people injured. Although the epicenter of the quake was situated 220 kilometers east of Pumori, the seismic activity caused the mountain to experience the most deadly avalanche of all time.
On April 6, 2009, an earthquake struck near the Italian city of L'Aquila. Killing nearly 300 people, it was a terrible disaster. You have probably heard of it because 6 Italian scientists in one government were later tried and convicted on criminal manslaughter charges for providing inaccurate, incomplete and contradicting information about the earthquake danger. They were sentenced to 6 years in jail, basically for failing to predict an earthquake. This riled up a lot of people in the science world, and with good reason. This is because while we know a lot more about earthquakes than ever, there is still no reliable way to predict them. Now, can we forecast where earthquakes are likely to occur over a long period of time? Yes. But seismologists can't predict the time, epicenter location and the magnitude. There's a lot of reasons for this, but it's mainly because it's so difficult to study tectonic plates. Tectonic plates are the giant slabs of the Earth's crust that are constantly moving around. Since they're usually at least 100 kilometers thick, scientists believe that earthquakes start when 2 or more plates meet. The process that occurs before they start is subtle and almost impossible to observe, but that doesn't mean there isn't potential indicators that can be studied or loads of intriguing anecdotal evidence that some people believe can help predict some earthquakes. For instance, many scientists think that the rising levels of radon are a good indicator of an impending earthquake. Radon is a radioactive gas produced by the natural decay of uranium. Radon builds up in cavities beneath the surface of the Earth and may be released by shifts in the ground preceding a quake. However, while radon leaks have preceded some earthquakes in the past, in many instances they also haven't. So in order to predict an earthquake and in turn send out warnings of imminent danger to the public, you need reliable and repeatable indicators. Unfortunately, they don't exist yet.